the local community. How can they benefit from digital QI? Let's find out. They would benefit from online access to good manufacturing practice guidelines. These assure efficient and sustainable production.
Muy bien, buenos días. Good morning. Before the start, we will give the translators the opportunity to give some information for the translation. Vamos, para los que están en Zoom, vamos a dar unas indicaciones para la traducción. Sheila, adelante, por favor.
Thank you. Good morning. I'm going to give you a brief explanation on the use of interpretation in English and in Spanish. Buenos días. Voy a dar una breve explicación sobre el uso de la interpretación en español y en inglés. When the interpretation option is enabled, you'll see an icon of a globe at the bottom of your screen where you can choose the language you wish to hear. Al habilitarse la interpretación, verán un globo en la parte inferior de su pantalla donde puede escoger el idioma que desea oír. In a few moments, I'll enable interpretation and we can begin. Dentro de unos momentos, habilitaré la interpretación y podemos comenzar.
Muchas gracias, Sheila, por la información brindada. Esto es para los que están participando por Zoom. Bienvenidos a este webinar que se realiza en el marco de la semana CABURK, relacionado con la metrología para la transformación digital, cuyos temas en esta ocasión son los certificados de calibración digital y la automatización de procesos en los laboratorios. Este webinar también está siendo transmitido desde Facebook y YouTube, desde diferentes institutos, y damos la bienvenida a los que nos ven desde las redes sociales. En el chat encontrarán los enlaces para que puedan compartir el evento con sus colegas. Por favor, compartir los enlaces en el chat. Mi nombre es Alexis Balki, soy consultor de PTV para la región SIM y los estaré acompañando como maestro de ceremonia durante este evento. Esta conferencia es organizada por el Sistema Interamericano de Metrología, SIM, con apoyo del Banco Interamericano de Desarrollo y el Instituto Alemán de Metrología, PTV, y el grupo de trabajo 14 del SIM M4DT del Sistema Interamericano de Metrología. Antes de iniciar con la conferencia, quisiera dar algunas indicaciones. Informarles que este evento se está realizando en la modalidad Zoom Webinar, por lo que los que participan desde la plataforma Zoom tienen que tener en cuenta que sus micrófonos y cámaras estarán desactivadas por defecto. En caso deseen activar su audio para realizar alguna pregunta, favor de levantar la mano para permitirles su intervención. Este webinar quedará grabado en las plataformas de transmisión a través de las redes sociales. Pueden realizar sus consultas durante la presentación en el chat. Una vez finalizado la presentación, él o los ponentes responderán a sus preguntas. Por favor, cuando hagan sus preguntas, no olvidar indicar a quién va dirigida. Como comenté, en caso desea encender sus micrófonos, levanten la mano. Para aquellas personas que nos están viendo desde las redes sociales, también pueden realizar sus consultas en el chat de la plataforma. Tenemos colaboradoras y colaboradores que estarán pendientes de las preguntas en las redes sociales. Para las palabras de bienvenida e inauguración del evento, nos acompaña la doctora Claire Sandry en representación del SIM, el doctor Casaburi en representación del Banco Interamericano de Desarrollo, y vamos a tener también un video de saludo del señor Ulf Zillner del PTV de Alemania, a los cuales les agradezco su asistencia. Primero doy pase a Claire. La doctora Claire Sandry es la presidenta del Sistema Interamericano de Metrología del SIM. Ella es directora de Asuntos Internacionales y Académicos del Instituto Nacional de Metrología de los Estados Unidos, el NIST. la doctora Claire Sandry, apoyó los procesos y el desarrollo de la transformación digital en la región CIM desde sus inicios, creyó en esta apuesta. Es por ello que estamos muy honrados y agradecidos que nos acompañe y que nos dé las palabras de bienvenida a este webinar. Adelante, doctora Claire Sandry.
Thank you so much, Alexi. It's really nice to see everybody today. Good morning, muy buenos días. On behalf of the Sistema Interamericano de Metrología, or SIM, it is my great pleasure to add my welcome to all the speakers and attendees at this webinar on metrology for digital transformation. I understand that the focus of this webinar today will be on digital calibration certificates and laboratory automation. And this is a great opportunity for engagement between the National Metrology Institutes, the secondary calibration laboratories, and industry on these very important topics. A big thanks to the Inter-American Development Bank and Gabrielle Casaburi especially, and to PTB and Alexis and Ulf for their support, continued support of SIM on this topic. SIM is privileged to have many institutional partners like the IDB and PTB that recognize the value of the metrology system for the Americas and the strong member network that we have cultivated over the past 4 decades. When SIM is called upon to help meet a regional need, our members find ways to support one another and establish new avenues for collaboration. This workshop is an opportunity for SIM to engage with its stakeholders on our efforts to develop metrology capabilities to support the digital transformation and to demonstrate, once again, the role of measurement science in advancing new and emerging technologies. I want to thank SIM Metrology Working Group 14 for their dedication and commitment to advancing metrology in support of the digital transformation, and each of you in attendance for contributing to this important regional effort. Thank you and best wishes for a very successful seminar.
Muchas gracias, doctora Claire Sandry, por su palabra de bienvenida. Y ahora cedo el pase a Gabriel. El doctor Gabriel Casaburi tiene maestrías en Ciencias Sociales y Relaciones Internacionales y un doctorado en Economía Política. Actualmente es especialista líder del sector privado en el Banco Interamericano de Desarrollo, en la División de Competitividad, Tecnología e Innovación. Es un honor tenerlo aquí para que brinde unas palabras de bienvenida a todos los participantes de este evento. Adelante, doctor Gabriel Casaburi.
Bueno, muchas gracias, Alexis, gracias, Claire. El honor es mío. Vuelvo a agradecer que me hayan invitado a participar en la inauguración de este seminario. Nosotros desde el Banco Interamericano apoyamos con mucho entusiasmo esta iniciativa. Los jóvenes de mi país últimamente cuando algo les gusta mucho dicen que algo es todo lo que está bien. Y yo creo que el SIM y este proyecto es todo lo que está bien en nuestra región. Es decir, está súper alineado con las cosas que el banco ha estado promoviendo en los últimos años en términos de integración regional, de desarrollo económico, de apoyo a pymes. Todo esto está basado en la infraestructura que la metrología da a nuestras sociedades para operar. De manera que el hecho de que exista un ámbito de cooperación, que es el SIM, donde todos los países del hemisferio puedan unirse para aumentar la escala en la que operan en estos temas, a mí me parece algo fenomenal, digno de apoyar y con mucho orgullo llevo adelante la tarea de representar al BID en su apoyo en esto. Llevamos ya muchos años, en el pasado el BID muchas veces apoyó los temas de metrología a través de operaciones individuales en cada uno de los países donde apoyamos la infraestructura de la calidad en el país. Y desde hace ya entre 4 y 5 años que estamos apoyando esta iniciativa más regional a través de un bien público regional, que es un instrumento que tiene el BID para apoyar justamente iniciativas que abarcan a más de un país en la región. Tuvimos una primera cooperación que fue súper exitosa promoviendo el tema de metrología para nuevas tecnologías y ahora estamos arrancando con esta nueva que es metrología digital, metrología 4.0, avanzar en la digitalización de las tareas de metrología en la región. Eso nos parece a nosotros súper importante, tanto que yo pienso, el banco tiene una nueva estrategia 2025, que tiene 3 ejes fundamentales, que son el apoyo a las pymes, el apoyo a los procesos de digitalización y el apoyo al proceso de integración de empresas latinoamericanas en redes y cadenas de valor globales, ¿no? Que el banco llama nearshoring, porque hay un proceso fundamentalmente en el hemisferio de acortar un poco las cadenas de valor y traerlas más cerca, ¿no? Por eso el nearshoring, más cerca de nuestras costas, y eso abre una oportunidad enorme para América Latina de integrarse a estas cadenas. Y yo creo que con este tipo de tareas, que quizás para los que no son del área puede sonar muy técnica, pero son lo que ustedes hacen en los institutos de metrología, pero específicamente cuando se unen en el CIM, contribuyen exactamente a estas 3 líneas de trabajo que son para nosotros prioritarios en nuestra visión. Así que con mucho entusiasmo quiero darles a todos la bienvenida, agradecer el apoyo del PTB también a esta iniciativa y desearles un exitoso taller. Muchas gracias.
Muchas gracias, Gabriel. Y bueno escuchar que el CIM está alineado a los objetivos del BIT en la región. Ahora invito a Ulf Seiler, representante del PTB de Alemania y también otro de los importantes aliados del CIM, a dar unas palabras de bienvenida. Esto será a través de un video. Adelante, Carlos.
Muy buenos días. Es para mí un gusto saludarles a todos ustedes y darles una bienvenida muy cordial en nombre de PTB a este evento virtual. Ya es el segundo taller en el proceso de CABURK para apoyar la transformación digital a través de la metrología. En este proceso particular, unamos fuerzas entre las 3 organizaciones, CIM, Banco Interamericano de Desarrollo y PTB, y me gustaría aprovechar esa oportunidad de agradecer a CIM y el Banco Interamericano de Desarrollo para esa cooperación tan fructífera. A todos ustedes, como participantes, coaches, expertos o coordinadores, les deseo mucho éxito en este evento que marca un hito importante en todo el proceso. Ustedes ya generaron muchas ideas y avanzaron para realizarlas, y espero que este intercambio en esos días, este intercambio de experiencias les sirve en el camino de poner en práctica lo que tienen pensado. Gracias a todos que toman su tiempo para compartir su experiencia al equipo que ha preparado este evento. Muchas gracias y mucho éxito. Saludos.
Muy bien. Le haré llegar las gracias asincrónicas a Ulf. Entonces, con esto damos por inaugurado este evento Metrología para la Transformación Digital de abril 2022. Pasamos a dar inicio con el primer bloque de la conferencia en el tema Certificados de Calibración Digital. Doy la palabra a Carlos Galván, el cual nos brindará la siguiente ponencia: una introducción a los certificados de calibración digital y los desarrollos con respecto al certificado de calibración digital. Carlos Galván es ingeniero en sistemas computacionales con una maestría en ciencias con especialidad en computación y matemáticas industriales. Desde 1995 trabaja en el Centro Nacional de Metrología de México, CENAM, en la Dirección de Metrología Dimensional. Adelante, Carlos.
Gracias, Alexis, por esta presentación. Vamos a iniciar. Voy a compartir mi pantalla. Por favor, me indican si todo va bien.
Sí, vemos tu pantalla.
Excelente, muchas gracias. Muchas gracias a todos por estar atendiendo esta presentación. Como se mencionaba, la idea de este webinar tendría que ver principalmente con temas de certificado de calibración digital y automatización de laboratorios. Ambos elementos están íntimamente ligados y forman parte de este proceso de transformación digital en la metrología. Vamos a iniciar entonces. Como todos sabemos, el producto principal de los laboratorios de calibración y uno de los productos de los laboratorios nacionales de metrología son los certificados de calibración. Los certificados de calibración donde se emiten los resultados de todas las mediciones que se hacen, donde se resumen todas estas actividades que como laboratorios realizamos. Todos estos se resumen, todas las actividades de mantenimiento de patrones, de control, de estabilidad, etc. Por eso es un producto bastante importante y de gran trascendencia para las calibraciones y las mediciones en todos los países. Actualmente los certificados de calibración los conocemos en su versión impresa o en algunos casos en una versión electrónica mediante archivos. Estos archivos pueden ser quizás en formato PDF, que es un formato de un documento portable con ciertas características que permite compartir esta información que se genera o que se transmite a través de los
is shared through calibration certificates, so it may be used directly through users, metrologists, industries, secondary labs, and each and one of the stakeholders of metrology and quality in the countries. Accreditation activities also must have access to this information. For this, if you see, we have mentioned what are these, who are these documents meant for? Well, they're meant for people. They're aimed, they're meant for individuals so that they may be interpreted, and so each one can recover the information they need, be it in the description of the equipment, calibration dates, and obviously calibration results, so that they may be used in the adjustments of the equipment whenever this equipment is being used, or in secondary calibrations, or in any type of element of the production line throughout the country, throughout the world where they're being used. So these certificates, regardless of whether they are generated in the country or used in another, I insist, are aimed at people. And this is why from these certificates, we not only see numbers and letters, but we also see charts, we see tables, which are meant for people to interpret them.
Actualmente nos hemos visto inmersos en este proceso de transformación digital, en este proceso de automatización.
So in this process of automatization of processes, labs, where there is a lot of intervention of automatic process of elements, machines, bots, computers, using IA and data processing, and any type of other communication means amongst us. So what happens now with this process? How do we interact in these calibration certificates in these new automation processes? It's important to be connected because this is part of a very important process. To date, this use that's conducted in certificates, it's done manually. Every data that we have needs to be uploaded either manually, either through our quality certificate, through our teams, through our internal processes, through our software, through our adjustment, curve adjustment, and any other tool that we require. All of this introduction is done, and all of this is uploaded manually. Why? Because we don't have a specific format for calibration certificates. Each one of us, each lab reflects its certificates, adjusted to norms, adjusted to standards, but free as far as format. There are different ways of presenting values. There isn't a standard to be able to do this. And as I mentioned, documents are meant for people, and so all of this work is done manually. Mistakes may be made. In this process for the 4.0, in the revolution of the digital transformation, there are several elements that can be considered. In this 4.0 industry, there's a data transfer to the physical world, meaning information of the physical world is captured and digitalized for creating a record in a computer. And then this process can then be shared through different elements. This may be done digital to digital. And at this phase, information is transferred through different systems for data analysis and different analysis and IA to discover the necessary information to make decisions, to share, to discover what is going on in this process. And then in this digital world, we have to go back to the physical world. Algorithms that are used to share this decision in data to stimulate the changes that are necessary. And so therefore, it is important to achieve an exchange of calibration data in a way that is more efficient without going through a human intervention, meaning have data in a format, so we can then download electronic files to other processes in such a way that interpretation of results takes place directly and not through human intervention to avoid mistakes into speed processes. So data can then be established through cloud services without having the need to file these resources anywhere else. What are the restrictions that we face? We are always talking about a communication process. We need to establish communication between the different stakeholders, amongst those that do the calibrations, the systems that run the calibrations, and then reflect these results for people or tools or the systems that are going to be using this information. At the end of the day, this is a communication process, just as we know it. To code and decode information, to provide an interpretation for the information, to be able to use it for whatever means we require. To do this, it is important to have a language such as the one that we are using and the one that we are communicating through. Thanks to the simultaneous interpretation process, we are able to understand each other through different languages. And this is why for the systems, it is important that we are now sharing in the majority of cases. This is an XML language. We will not go into detail now, but this is a language that can be easily understood through computers and electronic systems, and something that may be interpreted by humans and machines alike. So as soon as this language is determined, we establish a format. And so it is possible to see this exchange and what additional benefits may we acquire when handling this sort of electronic format. We can share the integrity in the data or maintain the integrity in the data. We know that we may keep what we are including in the document, and this is the data that we need to include. We may achieve confidentiality given these files can be adjusted so that anybody who has the key or who owns the information can actually use this data included in the files. We can achieve authentication to verify that this data, to ensure that this data are the data that is being used, that is being read, that it hasn't been altered, and just to be sure that the information that we achieve has the proper information. All of this through digital files to exchange information. This is a proof of what a calibration certificate is going to look like in the future. And as I mentioned, this is an XML file where we see the labels, and we're able to clearly identify each and every one of the elements, and where we may observe different languages to interpret it differently. To the left, I show you the tables of the data as calibration certificates are presented, and on the right, I'm showing you how a calibration certificate would look from the new structure that is being proposed. This new structure basically is made up in 4 main branches. Administrative section, which is administrative section of calibration, meaning, who does it? Who owns the equipment that we are reporting at the time? So all of the information having to do with this calibration data, arrival to the lab, so on and so forth. And the second section may be the most important one for many of us, depending the use that is given, measurement results. In this one, we include uncertainties, digital system units, and additional to this, we add other 2 layers, which are the comments that where we can include additional information of documents considered in the calibration process, and another section called documents, where we may also include a legible view or accessible for humans, or other important feedback. So that way we may close the communication cycle between an XML file addressed for the machine that can read it directly, but also a PDF that may be interpreted by people. This process for new calibration certificates has started a while back already. This is a proposal coming from the European Union, basically from labs like PTB, that have conducted a very important job suggesting this new proposal. I'm showing you now the page where you can see all of the information generated to date concerning calibration certificates, what the scheme looks like. We can also find videos and tutorials. So I think it's really very important that everybody having to do with methodology get to know this new proposal, and we start to really get involved with these new concepts. PTB has started their good practices proposal and has begun to design, to propose new examples or practical examples that may be used or replicated in the different labs. Furthermore, different labs, different national labs have also begun this process to use certificates for the creation of their own DCCs within their own countries. Thailand, China, Finland, Argentina, Mexico, and some other countries. PTB has also had very important development. Some industries have started, and as a matter of fact, in the session we have a presentation from VMX so that we may see how interesting this communication is between the different quality sections. Additionally, we will be able to see options and DCC. This is a proposal in a web page that will be shared. To do the calibration certificate. And at least what CENAM in Mexico has begun to develop. From these 4 stages that I shared, which is included in DCC. I have included the administrative section. We may also create directly the administrative section of data. And to date, we find ourselves in the phase of calibration certificates. Our scope will be towards several different calibration certificates. Not only are we adjusting it to a type of calibration certificate, but the intent is to be able to reach the majority of calibration certificates that are being issued.
Para poder hacer las pruebas y a poder terminar el desarrollo completo de los certificados de calibración en su totalidad. Este es un ejemplo de la plataforma que estamos desarrollando. Ya tenemos acceso a los datos para la sección administrativa, los cuales pueden ver que podemos ir agregando elementos nuevos, podemos ir navegando a través de los diferentes elementos que contienen el esquema de los certificados de calibración, aprovechando la tecnología que ya teníamos anteriormente. Anteriormente ya tenemos, o la plataforma que usamos actualmente ya nos permite generar certificados de calibración análogos, vamos a llamarlo así, aunque generamos un PDF casi de manera directa. Solamente la sección de resultados la subimos de manera manual a través de la responsabilidad del metrólogo. Sin embargo, la sección administrativa ya la tenemos actualmente automatizada. En esta sección ya estamos avanzando en la sección de medición de resultados. Ya podemos colocar los diferentes lenguajes, las fechas de calibración. Muchos de estos datos ya son tomados automáticamente a través de los sistemas que tenemos. No es necesario una intervención por el momento de los responsables de la calibración. Sí, obviamente, los resultados que estamos en espera de colocar esa información. Esta es otra pantalla de cómo cargamos los ítems, es decir, cada uno de los instrumentos de calibración que estamos realizando para colocar cada una de sus descripciones, su nombre, fabricante, descripciones adicionales, identificaciones que se puedan dar. Dado que esto es móvil en su momento y que debe ser verificado por la persona responsable de calibración, requerimos hacer ese paso.
Responsible for each area.
Esto es lo que esperamos en un momento.
So this is what we hope to be able to submit, the XML in accordance with the scheme that was proposed, but also a PDF version that we are including, and to conclude with this final part. Carlos, can I interrupt? There's a problem with the translation, I think.
Sheila, ¿me confirma si...
Sheila, can you confirm if everything is working? Yes, it is. Can you not hear the translation?
Sheila? ¿O Rocío?
Acabo de terminar la interpretación, pero sí creo que estaba funcionando. Yo estaba interpretando al inglés ahorita.
Sí, bueno,
yes.
hubo noticias que estaba fallando la traducción simultánea y que estaban hablando inglés en el canal español.
Bueno, vamos a tener más cuidado. Sí, voy a habilitar otra vez la interpretación, perdón.
Ya, ok. Muy bien, Carlos, por favor, continúa.
Sí, gracias, Alexis. Ya estamos por terminar. Como les decía, actualmente estamos...
As I was saying, right now we're working on placing our calibration results in the platform. Our initial proposal is to work through Excel sheets and then for reflecting the information, and then in XML. This is an initial proposal. However, we have been checking up on the scheme, looking into that, and as you will realize, when we started working with this, the main problem was that we have a different level for each of the processes. We've got calibration services that are completely automated, where the information has already been digitized and it's accessible, so the transfer would be very rapid. But there are other processes that, because of their nature, aren't fully digital, and for this reason, we need an intermediate step. Since the proposal is a global one, we're thinking of carrying out this process in different ways. This is another example of what we're working on. For the sake of time, I'm going to get ahead a little bit because I want to show you what PTB's been doing. These are some screens of the PTB related to the PTB proposal for resolving the generation of calibration certificates. And this project has been called GEMIME. This is a platform for creating certificates, and it allows you to introduce all of the elements manually, so that each of the fields can be filled out that are required for this certification. This is another screen, and you can see here how the information or the different elements can be entered here. And well, the GEMIME is a global proposal, and this can be used by the different institutes or laboratories that are interested in using the tool, and it will be shared very soon for this process. Thank you. And well, I'm open to questions and doubts.
Muchas gracias, Carlos.
Thank you, Carlos,
por tu presentación, y recuerden hacer preguntas. Vamos a tener la siguiente exposición y al final vamos a tener un espacio de preguntas.
We're going to have the opportunity after the next presentation.
Y cuando hagan las preguntas por el chat,
and
por favor,
when
no olvidar
you ask
indicar a quién
questions,
va
please
dirigido.
ask them on the chat, but please say
Ahora
who the
presento a
question is
Antonio
for.
Matamala,
Antonio
que dará la
Matamala.
ponencia titulada
He will
DCC
give a
from Industry and
presentation,
End User Perspective, la
DCC
perspectiva
for
de la
the
industria
industry, the
y del
perspective of the
usuario final
industry
con
and the
respecto a
final
estos certificados
user
de calibración digital.
regarding digitized
Antonio
calibration
Matamala es
certificates.
Country
Antonio
Manager de
Matamala
BIMEX.
is
Tiene
a
más de 20 años de experiencia en la
manager
industria del
of
hardware
IMEX
y
with
del
over
software
20
empresarial,
years of experience
con un
with
fuerte
business
enfoque
hardware
en
and
las
software,
soluciones de
focusing on
Internet industrial de las cosas.
industrial internet
Estudió
solutions.
ingeniería
He
medioambiental en los
studied
Países Bajos,
environmental
donde
engineering
se
in the
involucró en los
Netherlands
procesos de tratamiento de aguas
and
industriales y la tecnología de la información.
the treatment
También
of
tiene un MBA de
wastewater
la Open University Business
and others.
School
He has an
del
MBA
Reino Unido.
from the Open University
Lleva
Business School of
20
the
años
United
viviendo en
Kingdom,
Alemania
20
y
years
habla
living in
con fluidez
Germany,
alemán,
and
holandés,
he speaks
inglés y
German,
español.
Dutch, English, and Spanish
Le
fluently.
apasionan las cosas que funcionan
He
bien
is passionate
y
about things
que
working
tienen un
well
alto valor estético,
and
como es
having
el caso de las
also an
soluciones de
aesthetic
BIMEX. Ustedes parece
value.
un poquito propaganda para BIMEX, pero ahí nos vamos a mostrar cómo
The BIMEX
cómo lo hace.
solutions have
Entonces,
demonstrated this. That's a
adelante,
bit
Antonio,
of
con tu exposición.
publicity for
Tienes 40
BIMEX.
minutos.
You have 40 minutes, Antonio. Go ahead. Thank you very much. Thank you for the invitation so that we can contribute to this very important event and also to be able to share information and give you a view of the industrial standpoint. I'm going to share my screen
Adelante,
right now.
la estamos viendo.
And we can see it. Good. The focus of my presentation on DCC is as follows. We've been working as a company, a private company, with the private sector, but I'd also like to emphasize that there are no limitations, in fact. There's no significant limitation between the private sector or limit between the private sector or any other sector. And we're going to see in a minute why it's important to take this into account. I'm not really doing publicity for BIMEX, but however, BIMEX is a company that you have probably heard of, and our aim is to provide calibration technology for the process industry And we have many different areas, pharmaceutical laboratories, chemicals, and so forth. So it's quite a broad range, and that's an advantage as well to be able to speak on behalf of the industry in that sense. Although during this presentation, we're going to focus on the pharmaceutical industry specifically. For you to form an idea of what we do, we have products, we have hardware calibrators for calibrating sensors, temperature, pressure, and furthermore, we have software systems for managing information, the information of calibration data, and web-based solutions. And this is what I wanted to tell you about BMX, that's all. Because obviously, as a company, a technology company, we concentrate on problems. Basically, one of the challenges, we could say, that we face is that our clients receive calibration certificates. Very often these are paper ones, or maybe they're in a PDF scan, and they receive them from calibration supplier services. And these suppliers aren't necessarily external. It could be a private company that provides that service, or it could be a laboratory of any kind, or it could be a team within the company itself. And since we have companies of different sizes, we know very well that the larger companies do have their own equipment. They have external equipment. And once we are managing the calibration information, it's a challenge when you start to receive large amounts of information or of data. So as we can see in the photograph, I think, well, if you receive a document in a paper document, it's not really a huge problem to enter the information manually into a system, right? But the point is as follows. The motivation, this was the motivation for having started this proof of concept with the industry and with PTB. The challenge emerges not when you have to enter the information from two pieces of paper onto your computer, but when you have to work with 10, 20, 100,000 calibration certificates a year. And this obviously is a problem for larger companies that have an international or global focus. And this isn't an exception. This is the reality at present. Several years ago, we contacted PTB with a German pharmaceutical company, and we formed a working group to try to understand, first of all, what the aim would be with DCC, and at the same time, understand better the processes of a company of that size, because they were aware of the value of this for a very simple reason. If a company works in 15 or 20 countries and produces in those countries worldwide, and they have all of the information centralized in a single site. In this specific case, it was in Germany. Obviously, it's a problem when the information is submitted in whatever way. And as Carlos said before, we need to speak a single language to be able to understand us. With translators, perfect. That'll help us to understand languages that we don't know. But it does become become more problematic when each company that provides a service related to calibration starts to use any kind of format, whether it's digital or on paper, but the design too. So how the information is entered, that's just as important because of the interpretation of this information. So that's where DCC is a very significant and very interesting beginning, not just for the PTB that launched the idea, but also for the industry in general, and also for us as a company, a technology company, because what we do basically is we create solutions for our clients. The objective is this. Basically, the objective is if the client, wherever the client may be, works with many, many different suppliers that provide calibration services, they would hope to receive a DCC so that the process becomes automatic. In fact, well, in many cases, we haven't actually achieved that. There's still a lot to do, but we have taken huge steps. Because when we work in the pharmaceutical sector, it's not a question of entering data or a coordinator entering data on paper. It actually has to be done by two people. This is a principle. There has to be somebody entering the information and somebody controlling the data to make sure that the data that was entered is correct. And this obviously leads to further complications for this work. So I think then the reason is very clear why there is so much interest by the industry, because they are the ones who have to tackle these difficulties regarding the standard in order to improve the process. It's so important. I think that for those of you who travel, the problem, you can see it here, it's pretty obvious. You go to one country, you arrive at the hotel, you want to charge your laptop, and you discover that you don't have the right plug. So you go down to reception, and hopefully they'll be able to help you out, but not necessarily. So this is a situation right now where what's missing right now, and what we're trying to develop step by step, is a solution in order to translate local data into a solution that will allow the end user or client to improve their information management. And I think that information management in industry in general, well, is quite clear. And I think that we don't need to explain that. We have been right from the beginning working to develop or to apply DCC in certain environments. And what we've seen is that for some, DCC creates an opportunity in order to promote digital transformation in metrology. Other people see it as something that's pragmatic. Instead of entering information manually, you can do it automatically. And during conversations that we have held, some people have said, well, it's only an XML file. How difficult can that be to implement? And that's a very interesting comment, because when you start to work with people that are putting this into practice, you start to realize that there are a lot of details that need to be taken into account. PTB has been an institute that's developed this concept, this format, taking into account, obviously, these aspects effects. And this is why the structure is based on a core which is regulated, and to the extent that you back away from this core, then you need to take certain liberties in order to match the information, because sometimes it's somewhat arbitrary. However, this finally is translated into an XML file, and we've seen in a screenshot in the other presentation, but this is a concrete example of what the information would look like. So now, if you open this file, and if you have some IT knowledge, you can determine what the content is. However, I think it's important to think about the final user, the end user, and who wants to use technology in the easiest way possible without having to face so many challenges. And what we have here is that we have created a demonstration using our technology, and the link you can see in the next page. But I wanted to explain a little bit about what you can expect. We have created specifically a situation that is, well, a typical one. On the one hand, we have an industrial client, and also we have a service provider. The service provider goes out into the field and calibrates the sensors with the tools that they have available. And for practical reasons, we've done this using our technology. And what happens is that this person will go to the plant and carries out this calibration process, and then in the office sends or gives the information to the calibrator through the software, and then through a device shares the information or the calibration data with their client. So the client receives the DCC, and we've managed to carry out this experiment based on an XML version approved by the PTB, which reflects the needs of this pharmaceutical company. And this is part of a more global environment where there are more pharmaceutical companies represented. And I think this is very interesting, because when you see the video, you can see that that's what the future should look like. This really isn't new. I think that in our private lives, we already work in this way. So in metrology, we are still inventing the wheel somewhat, and I think that this is a reality. And it provides us with a great opportunity so that together we can advance with this. I think also that for those who are interested, well, that this is the link. I think that we will be sharing the presentation after this event, and I invite you to take a look at it. It's in English. In our experience in the proof of concept, we've seen that basically what's happening is that we are calibrating more and more, but also the suppliers with their own teams or external teams are also generating a large amount of information, a significant amount related to calibration data. And if you imagine, and I did this myself too, but if you can imagine that a company provides this service not only for an industrial client, one client, they might have 50 or 100 or 200 clients. And an industrial company doesn't just receive support from one external area, they also provide calibration. It could be 5, 10, 20, or 40. So if we start to draw or trace this network, this sharing of data, we would be in a situation with a large amount of data. And for this reason, we have to start to think about, as an industry, how we can solve this or how we can improve the processes. Because at the end of the day, and this is very important to understand, this industrial company, well, they calculated, and it wasn't just a use case that they had, but a business case. So time, data quality, auditing processes would be easier, etc. So it's not just a whim from the technology world, it's actually a need. So to the extent that we advance more and more with this, we've started to realize that it's not just important to validate the format and the standard, but also to start to think about how we can effectively share information. So basically, we're speaking about interoperability between two stakeholders. It's interesting, or it's easy rather, you could do it through email. But what happens if we have 10, 20, 30,000 a year from 20 suppliers? This, we start to create a transaction network, which is quite complex. And I think one of the ideas that has emerged out of this proof of concept is that we have to think about these terms. Because if on the one hand, we are solving the problem regarding being able to share information easily, then this could lead to another problem, which would be how to manage information. Because, well, if you don't have information, obviously, a lack of information is a problem. But when you have too much information, this leads to another problem, which also has to be solved. And this is why, step by step, we've started thinking about possibly one of the ideas could be a DCC platform where different actors are capable of sharing their DCC files. So this should be done, it should be user-friendly, it should be open, it should be easy. That's very important because interoperability exists when systems are open, we could say. Nobody would be interested in exclusivity regarding the use of DCC. That's not the spirit of it. The spirit is to create a format, a single one, which is easy to understand, easy to share, and the rest are tools that will make it possible to share information more easily. I like the idea of sharing this with, for example, when we think about Spotify, I imagine that you've heard of Spotify, this service where you can go and you consume music. Before, we'd share a CD or a cassette or an LP, depending on your age, of course. But today, nobody shares physical objects or CDs. What we do is we go onto the internet with your mobile or whatever device you have, and you sign up for a service such as Spotify and you consume music. So this is the analogy that I think is useful for understanding where we're going on this journey that we've started, but we're still at the beginning of it, really. The value, I believe, that's obvious for those who consume music because it's very easy. But the most important thing is not to use a physical means.
Intercambiamos información, mandamos papel. PDF es como casi papel. Yo pienso que por ahí, tendremos que ver paso por paso cómo facilitar el intercambio de la información. O sea, fase 1, la primera fase podría...
Phase 1, the first phase can be validate BCC, apply it in different environments. And, once we have this solved, phase 2, I believe is going to be depending on the amount of information that wants to see how we can exchange, how we can manage exchange per se, and we are going into interoperability. So right now, I am in Germany, and where we have this whole movement, this idea, there are very flagship projects at Vanguard 2, and I'm not going to focus too much on that, but there is a great interest in by the Ministry of Economy, which is funding this particular project beyond the companies that are participating, and these are funding the meeting, making available specialists, time, resources, so on and so forth. And what I think is really very important at this point is that simultaneously, there is another project in Germany that is called the Digital Data Chain Consortium, that, as a matter of fact, has as a goal, and maybe a little bit more broadly, investigating and to what point we may create a platform may be created to exchange technical data. And this is a movement that is interesting and that is important at the same time, because I feel like if one way or another, these movements show simultaneously, it's because there's a real interest. There is an interest based off and a real need that is out there. And I believe that Industry 0.0 is one of the engines that has been pushing this type of consortium, where, dozens of companies meet, important companies meet, because they want to bring digital transformation into the future. And I believe that, those of us who are focusing in metrology obviously fit perfectly well in this broader space. And this is why we are there. We are participating in these movements. And that's basically what I wanted to share with you. And that is my if there's questions, there's answers. I have my email, and I assume we're going to be sharing this presentation, where you will find the link to watch the video. Thank you so much.
Muy bien, muchas gracias,
Thank you,
Antonio,
Antonio,
por esta interesante exposición de la perspectiva de los usuarios. Hay preguntas en el chat.
Are there any questions in the chat?
Preguntas que van para Carlos y para Antonio.
Questions meant for Carlos
la
and
primera
Antonio.
Pregunta sería para
Carlos.
Question would be for Carlos. De Cristian Paredes,
from Cristian Paredes,
que dice Tengo una
saying,
pregunta para Carlos Galván.
I have a question for Carlos
En el
Galván.
futuro, el
In the
CENAM
future,
pondrá la plataforma
CENAM
generadora de
will,
DCCs a disposición de los
provide
laboratorios de
the
calibración de México
DCCs generating
para
platform
facilitarles la
available
generación
for
de
Mexico
DCCs.
to facilitate the generation of DCCs.
Gracias, Alexis.
Thank you, Alexis.
En este momento nos encontramos
Right now, we find ourselves defining the DCC's policy for CENAM. This is a proposal that is under review, and we will be publishing the results shortly.
Muy bien.
Very well.
Tenemos todavía
We
15
also
minutos
have
para
15 more
preguntas y
minutes for
respuestas, así que
Q&A.
por favor,
So
si tienen más
if
preguntas,
anybody has any
ponerlas en
other
el chat.
questions, please put them in the chat.
Aquí hay una pregunta del canal de YouTube en español.
We have a question from
Para
YouTube
Carlos
in
nuevamente,
Spanish.
en la propuesta
For
del
Carlos,
PTB, ¿cómo se
in the
maneja la
PTB proposal,
encriptación de la
how do
información?
we handle
¿El
information
formato
encryption?
XML va a ser el
The XML
estándar para
format will be the
elaborar los
standard
DCCs
then
o
to
existirán
draft
otros
DCCs, or
formatos?
will there be any other formats?
Gracias.
Thank you.
En la propuesta de encriptación,
The encryption proposal is also still under review. There are several proposals, and it's still to be defined which one will be the one used. Given that we are at the very beginning of this, we are currently focusing in the definition of the scheme of the format, what to include, what not to include in the certificates, and that work is currently underway. Teams are also working in encryption, but that is still not completely agreed. And the second point concerning whether or not the format will be standard, that's general idea. As I mentioned in the presentation, and as was reaffirmed by Antonio, I believe what's important here is to define a language, a common language, a single scheme to do this. I enjoyed what Antonio mentioned in the sense that if this is not open, if this isn't shared, we will not achieve the success that the DCC platform is seeking to obtain. So the idea is to take this XML format as an opportunity. There are other ideas, other suggestions outside this proposal. However, what under my perspective is leading the way is the XML proposal. We are hoping that this is what is being achieved, but that is the general idea, to have a single scheme, a single language, to be able to share information and make sure that this is successful, so that the restriction not only is per country, per institute, but rather a international proposal, a worldwide proposal, something that may be accessed by any person having to do
Muy bien, entonces creo que entiendo, Carlos, que tú también compartes
Carlos, I
el
understand that you
Spotify
share
DCC del futuro
Spotify DCC of the
como
future
propuesta de Antonio.
as Antonio's proposal.
Ok.
Yes. Great.
Entonces,
So,
aquí una pregunta para Antonio
question
de
from
Gustavo
Antonio,
Boglio
from
Marcet, que
Gustavo
nos acompaña
Boglio,
a través del
Marcet,
YouTube.
who is with us through YouTube.
Para calibrar instrumentos en procesos,
To
hablamos de
calibrate
calibraciones trazables,
tools and
o sea,
processes,
calibraciones con
talking
toda
about
la ley.
traceable
Y
calibration.
para los equipos en línea,
And
¿cómo
for
consideran
online
condiciones de
teams,
contorno
how do
en las
you
que se
feel
calibran estos equipos en línea?
conditions where we calibrate these equipment online? This is a question I think more meant for hardware, how to calibrate online. And finally, I would say that this is a really good question, but ultimately the DCC should be observed as a system to exchange information, which should be seen completely independently from the team that is collecting it or is generating it. Interoperability is really find a common language, and there should be no difference in that sense between using BMX equipment or any other company, or we calibrate online or in a lab or in on the field. And so this is kind of what we have to go
Es decir,
for.
las calibraciones en línea también van a ser calibraciones
Yes, online
trazables.
calibrations will be then, of course,
Yeah.
measurable. They should be. And this, I mean, we have to ask a specialist how to generate a DCC for this environment.
Muy bien. Muchas gracias. Después tenemos una mano levantada de
Great.
Natalia
So we also
Vega.
have a question from
Aquí en
Natalia
el
Vega
Salón Zoom. No sé si
here in the Zoom lounge.
ya. Natalia, adelante con tu
Natalia,
pregunta.
please go ahead with your question.
Natalia, ¿nos escuchas?
Natalia, can you hear us? You have to activate your mic.
Bueno, mientras
you have the
preparas
floor.
tu pregunta
Okay,
y
so
la
while
posibilidad de hablar,
you prepare your
continúo con una
question,
pregunta aquí
I will go
en el
on
chat,
with a question that it is here in the
que
chat,
viene de
which comes
la
from
red Facebook en español.
Facebook app in
La
Spanish.
primera pregunta ¿es posible tener los links a las
Which is,
presentaciones?
can we
Y
have
sí,
a link to the
esto
presentations? And
van a
yes,
estar en la página web
and these will
del
be
evento.
available
Y me
on
ayudan a
the
compartir la
event
página web del evento,
webpage.
por favor,
And
en
please
el
help me
chat.
share this in the chat.
Y la pregunta 2,
And
¿existen,
question
de
two
repente está
is,
para
are there
Carlos,
any,
existen reuniones
this
con
is for
alguna
Carlos, are there
institución de
any meetings
normalización que vaya a
with
incluir esta nueva terminología, por ejemplo, el
standardization
DCC, y
institute
líneas de
that
buenas
is going
prácticas
to
en la
make this
calibración, por
technology
ejemplo,
available,
en la
DCC,
17025?
Calibration 1725?
O Antonio, no sé,
Or
¿quién
Antonio?
quiere responder?
I don't know who wants to answer. Yes, please, Antonio, go ahead. No, Carlos. Actually, yes, we are sharing this right now because we are in the development phase. We are establishing the standard, but obviously we will be included in the norms. There should be a standard. This is, of course, not available as an ISO, but at a certain point, I mean, this could, of course, be introduced. Because this will be a need, a requirement. We have also conducted training courses for auditors to actually teach them how, the DCC will be a reality, and so that this isn't a surprise for anyone. This goes beyond, a lab or a private company. This is a whole environment that will need to have to start getting used to see how you're going to treat calibration in the near future.
Muy bien. No sé, Hugo, si al respecto querías comentar.
Did you want to mention something, Hugo? Yes, of course. Thank you, Alexis. Indeed, we are in very advanced stages. There are aspects which, standardization, auditing, quality that goes beyond, that are linked to the information from the certificates, from the calibration certificates, and there is already activity. And obviously, we're going to intensify the collaboration with these other agencies, international and national agencies. And little by little, we're going to be sharing this information through the different activities. Particularly, we have collaboration with the fund, CSLI from Canada. And eventually, this is going to require a training, as Antonio mentioned, for auditors, for crediting companies, and maybe the use of digital calibration certificates. But as Carlos mentioned, this is going to have an impact on production lines, value-added chains in the industry that is automatic, that this is a machine-machine calibration.
Sí, aquí hay en el Facebook con respecto a esta pregunta.
Yeah, in Facebook we have another
Hay varias
question.
preguntas con
There
respecto a
are
la
several
normalización.
questions concerning
La de Alan Fernando
standardization,
Figueroa
Alan
Rodas,
Fernando Figueroa
también
Rodas,
desde las redes sociales.
also from
Está
social
Está
media.
respondido la pregunta si había alguna norma que hable del
Question
DCC.
is there any
Actualmente no la hay.
standard talking about DCC? To date, there
Y
isn't any.
Celestino Meneses
And Celestino Meneses
del Facebook en inglés pregunta si esto debería estar
English
en una
Facebook
norma
asks,
ISO para el
should this be
formato
in an ISO
DCC.
standard for the DCC
Y
format?
aquí hay un
And,
comentario de Daniel
here we have
Wilhelme
a
del
comment
Facebook en
from Daniel
español
Wilhelme from Spanish,
y pregunta si no se vio la posibilidad de trabajar con el V3C para desarrollar normas de comunicación entre laboratorios y usuarios. Esto sería bueno, dada la experiencia de este grupo o de este comité V3C, que no lo conozco, pero no sé si alguien lo conoce. No sé, Carlos, si puedes comentar.
Carlos, I don't know if you have any comments.
Sí, no hay un trabajo tan directo con el W3C.
Well, there isn't that much of a direct contact with the HTC, but the XML, the standards that are being used are based on the proposals of this particular group. So there isn't an indirect connection with them as far as I'm concerned or I know of, but these formats are being used and they are based in this scheme to be able to develop in XML and DXML.
Muy bien. De aquí hay una pregunta de Marcos. ¿Cómo se asegura el resguardo de la privacidad de información en el intercambio de información digital con los
make
DCC?
sure you have an exchange of digital information with the DCC?
No sé, Antonio.
Antonio?
Privacidad en cuanto a
privacy as whether somebody sends a DCC.
Revelar la persona que envía la información o más
We can send it to a person that sends the information or the company.
Es un factor importante.
This is actually a very important aspect. So this issue of privacy, but encryption, safety and security, information being transferred. I mean, these are all being considered. These are all being included, and obviously it adds certain complexity to just the XML database, which is where I believe experience shows. At first we thought this is all going to be very easy in the sense that, okay, so we have an XML database when what's going to be hard is going to be sending it, right? But if you start going deeper into the subject matter and see how the pharmaceutical company works, because of the FDA has its guidelines, its demands. So it doesn't make things easier, but it just kind of makes it more interesting. I believe that all these issues are being considered, and it will end in technology that will allow for encryption and safe transmission. But as Carlos mentioned, we are these are the early stages. Future is still to come, but we're learning to walk.
Una pregunta personal y
a personal question,
si puedes contestar corto. Tú has puesto la perspectiva, digamos, de una gran empresa con muchas calibraciones y el valor de utilizar el DCC. Si fueras un gerente de una empresa, de una pequeña empresa, ¿cómo te posicionarías ahorita en este proceso de desarrollo del DCC? Si lo puedes responder corto.
Process. If you can answer in short, as an industrial company or a service,
una empresa industrial.
Service company? No, an industrial company.
Mientras vas pensando, le voy a hacer la otra pregunta a Carlos. Aquí una pregunta interesante. ¿Cuándo crees que vinculen la octava unidad del sistema internacional? Cantidad de información. ¿Cómo ve el alcance de esta nueva magnitud?
How do you see this scope? Well, I think we're still far from that proposal. it is not being considered in the near future. There are other greater concerns at the moment, but yes, we'll definitely be looking out for this.
Y la pregunta rápida en inglés, if we include
Quick
DCC,
question.
can we affirm that we are into Metrology 4.0, Carlos?
No, definitivamente no. Es solamente un
No,
paso.
definitely answers no. It's just a step. DCC is only a tool to include metrology within the 4.0, but there are to prompt within 4.0, but there are other elements. This is a great tool, of course, and it'll be necessary with that DCC. We cannot move on. We cannot even think of 4.0 metrology, but when speaking of 4.0, there are other elements needed for this. So we are thinking in big data, we're thinking of metrology, we're thinking, many other elements to really consider 4.0.
Muy bien, muchas gracias. Y Antonio, cortito porque ya se nos acabó el tiempo.
Sí, perfecto. Mira.
Yes, summarizing, I would say the following. DCC is an open format, and so if you have any knowledge of IT, you may develop a tool that generates a DCC. It's not forbidden, right? So in the phase we find ourselves in at this point, it's what we may call early adopters, people who like to be, the cutting edge, right? And so I believe it's going to show more interest. Now, if I don't want to focus on resources, I absolutely, without any question in mind, would advise any company to be very much aware of what is going on, because it may happen that at any given time, even companies that develop or that create sensors may in the future not have a sensor in paper. They can put it in the so what I'm saying is that the environment limits us to specific stakeholder in their ecosystem made up by so many stakeholders that if we begin to use this DCC, then we can then move forward step by step, and those that have more interest can move faster. And this will be like a temporary window that's going to allow everybody to find their own rhythm.
Muy bien, gracias Antonio.
Great.
Y digamos,
Thank you, Antonio.
estamos realmente en
we
una
are
fase de
really
innovación y
in a
desarrollo,
very
y
innovative
cada uno
and
tiene que encontrar
development
su
phase,
sitio
and everybody has to find their own
cómo se va
place
a
and
posicionar
how
en
they're going
esos
to
espacios.
position themselves within these spaces.
Ya se acabó el tiempo, entonces la pregunta de
time is
Roberto
up.
Chala
So
y
Roberto
de
Chalas
Celestino
and
Meneses,
Celestino
la vamos a ver
Meneses'
si la podemos
questions
retomar
are
al
going
final.
to, we're going to see if we have time for them.
Y agradezco todas las preguntas,
Later
agradezco a los
on, and thank you
ponentes.
so much
Muchas
for the
gracias,
questions. Thank you for all
Carlos,
our guest
Antonio
speakers,
y también Hugo, por tus
Antonio,
comentarios.
Hugo, for your
Entonces,
comments,
un aplauso para
and
ustedes.
a big
Y
round of applause
pasamos
for you, and
al segundo
move on
bloque,
to the second block
que es
of our agenda,
el bloque de automatización.
which is automatization.
Este bloque tendrá 3
This
ponencias.
block has 3 presentations.
Recordarles que pueden hacer las preguntas a través del chat.
Just remind you that you can ask your
Y al
questions
final
via
del
chat.
bloque también va a haber un
At the
espacio
end of this block, there will be
de respuestas.
a space for Q&A.
Y por favor, no se olviden de indicar
Please
a quién
don't
va
forget
dirigida la
to,
pregunta. Me hace más fácil el trabajo. Como primer ponente tenemos a Rubén Gil, quien nos presentará el tema Visión General de la Automatización de Procesos en Laboratorios. Rubén es ingeniero en telecomunicaciones, egresado de la Maestría de Ciencias de la Electrónica, con mención en Automatización y Control. Tiene experiencia en el desarrollo de proyectos y servicios en el área de flujo de gases del INACAL, el Instituto Nacional de Metrología del Perú, Experiencia en calibraciones, auditor como
Metrology
experto
Institute of
técnico
Peru,
y desarrollo de
and,
proyectos de automatización de
project
procesos en
development
los
and
diferentes
automation
laboratorios de
of processes
calibración
in
del
different
INACAL.
labs of
Actualmente es el coordinador del
calibration
grupo de
labs.
trabajo
In INACAL, he's
de
a
automatización
work
de procesos de
coordinator for
laboratorio
automation
del grupo de
automation
trabajo
of processes
14 del CIM.
in the
Adelante,
14
Rubén.
group SIM. Go ahead, Ruben. Thank you, Alexis, for the present introduction. Let me know if you can now see my
Vemos tu
screen.
presentación. Sí.
Yes, we see your
Adelante.
presentation.
Buenos días o buenas tardes con todas.
Good day to everyone.
Gracias por su asistencia.
Thank you for being here today. I'm going to be speaking about a general focus of project automation and calibration processes before getting started. I'd like to have us understand the meaning of what automation means. When we talk about automation, we talk about a very current or common term these days, where we basically focus in, there isn't any human participation in this process, or there could be a minimum human participation. So we're talking about automated processes or semi-automated processes with certain level of automation. To be able to achieve this, we need to digitalize information. And in English, there are two very interesting
La parte izquierda, que son diferentes.
terms. So in English, it's two words, but in Spanish, it's the same. While in the first word in English talks about sharing an analogic system. The second word focuses on adding a value to the digitalization. For example, a metrologist conducts a process and actually jots down the data on a table on a sheet, and then so that this information isn't lost, it is then scanned. So they digitalize the information, but they're not giving it any value. Imagine instead of scanning this document and saving it there for later audits, they include it in an Excel sheet or a software because it has an automatic acquisition system, and they add value to these elements, maybe running numbers, determining certainty. So why not generate a calibration certificate? So we're actually adding value. And this is why I wanted to mention these two words, which I believe are so interesting. This, a process from the labs in general may be divided into multiple phases. And so this is, I wanted to do it in these four due to practicality, or for practicality purposes. I want you to focus both on calibration service suppliers and as a client. So take both positions. Speaking on the first phase, as suppliers, what forms do you have for user assistance? A user wants to conduct or provide a service, and where they find a service of the calibration services that are offered. Or let's begin with the customer first needs to know what institutions offer this service. Where can we find this information? Is this information readily available in the webpage of the International Metrology Institute? Do you download it from a huge Excel page, and then they have to find a way to find that information? Is it easy to conduct this search? So we should focus on, for example, once a client knows what institution this service may be reviewed in, or how to conduct its request through request it through a platform that works 24 hours a day, or maybe that only works during office hours. Or do they have to send an email? Do they have to call? Do they have to go near the institute? We are actually talking about different levels depending on the reality of each institute. Once the user manages to get this application, and then we have to figure out what the measurement tool will be. How do you send this? Have you heard or know about a lab that allows delivery of calibration tools, anybody that, they have their staff go in, or maybe update the service through a courier? Or do you send the calibration tools to a lab to provide the service? How is this done? And once it arrives, how do you record this calibration tool? If a lab these tools to do follow-up on these tools, we do it through a QR code, to your FID, a barcode, serial number to a control card. So there's different ways. So we ask ourselves, how does a secondary lab, how does a Metrology Institute go over this identification?
Once the instrument has been entered and is sent to the laboratory for the process, how does that process occur? Is it automatic? Is it semi-automatic? Is it fully manual? Let's remember that this means, well, in this process, everything has to be not everything has to be automated. There are some processes that don't need this because of the way that they are worked on. So it's important to make a prior analysis. This calibration process is carried out, and then we have to send out the information. Where to? Maybe to a spreadsheet, maybe to software, other software, and then the error is calculated, and this will result in the calibration certificate regarding the printing and submitting it to the client once they've collected the instrument or scanned and then sent to the client by email. And maybe the signature can be put in or scanned, or the signature of the representatives of the laboratories have been scanned and the image can be copied onto the PDF documents. Or maybe it's an electronic signature, or as was said before, we could be speaking about we're speaking about a DCC, so there are different levels during these stages. But regarding the first level, quickly, as a client, for example, I would like not to have to go to the institute in order to request a service. I'd like to have a friendly platform so that I can enter, but also with security, and I can enter information easily, and I can enter my application, find out when the service is going to be provided, and then I can program this as well, maybe in 3 months' time, and get automatic quotes, pay online, and all of these aspects are beneficial for the final user. Regarding identification, there are different institutions. This is a regional talk, so we're speaking about different institutes, national metrology institutes, and different secondary laboratories, different industries as well, that as the internal process provide these calibration services. And the registration of these instruments is carried out in different ways, as I mentioned a few moments ago, through barcodes, QRs, follow-up quite simply, or scanning the code or the file. And this is significant because it's thanks to this that we can add value. Let's imagine that we have a measurement instrument that maybe is for legal metrology. And in this sense, the compulsory nature or the mandatory nature of the frequency of the calibration could be once a year. But that's decided on by the user. So if I have the information in my system regarding the measurement instrument, then I know that the calibration is annual, and it has to be this way because of legal requirements in the country. In this system, I wouldn't be able to add an algorithm, for example, 2 months before, 3 months before, and after a year, maybe send an email to the client indicating that they can start with their process of requesting the service. And this would be information, some information that we already have because we've already entered it, and we need to take advantage of this information, not just to benefit the laboratory, but also the client. So this would be an added value for this of the digitized information. So for this, we would have a lot of measurement instruments. Sometimes the calibration measure is direct. In other cases, there are different measurement instruments used. So for this, we have sensors, we have transductors, we have a large amount of different instruments depending on the magnitude of the service. So if I want to use this information for an automatic system, data update, controlling variables, etc., I need to use electronic cards. These can be industrial cards such as the PLCs, or they could be general cards or cards developed by ourselves or by a third party. There are instruments that have a communication interface, and I can connect directly to read them. And sometimes I need to enter the information manually. But it is necessary. If it's necessary to digitize, then I can do this, and this has been done through image processing, for example, by using a camera. There's a large number of ways of digitizing information in order to carry out this automation process. Finally, this information will go to the software. The software can be developed by a private company, by a third party. It could be developed by an IT organization or by metrologists. And we've seen that many people use different platforms, different programming environments, Excel, and additional things have been created in this regard. So it isn't limited to using a specific language or a specific software. That isn't the case. It depends on each person's reality. Once we have this information and this system, we can register the calculations or measure the level of uncertainty so that we can continue with the process. At the same time, it's possible to have other systems that connect to the database for calibration. And this is an advantage because once we have these data digitized and once we send it to a database, we can migrate much more rapidly. This was commented on before regarding a digital calibration certification, because we already have the data. We just need to generate the format, and otherwise, or we could send another, check the database and look into the information, the corresponding information. So these are the processes, but perhaps it would be a good idea now to speak about the advantages of automation. The fact of developing our own technology using commercial cards or our own cards and our own software, this allows us to integrate processes more rapidly for our institute, unlike having equipment such as black boxes where it would be much more complicated. If we have an automated system and we develop a process using this system, this is beneficial because we'd have a better learning curve for the new metrologists, because they would find a more simple process, and this system will protect and will provide security to the metrologist depending on the process. It'll also provide security for the process, and it can activate an electronic valve in case of problems. So these processes can generate alarms, warnings, if we have an automated system. Obviously, when we carry out these processes, This represents an investment. We need to have personnel with knowledge of hardware and software development. This is very important because if we start to subcontract these processes and we want to add something, we're going to have to call on these people again. But if we have our own human resources responsible for it, they can carry out any updates. I'd like to talk to you about some projects that colleagues from different institutes have been implementing, such as digital customer service platforms. During the pandemic, these have been improved. Many of these processes, a lot of colleagues have developed a procurement system using microprocessors, micro images and software in order to automatically read the measurement instruments that have an interface and to automate the testing and carry out automatic repeats and also enter the data rapidly. And in some cases, we could even improve certain components related to uncertainty, unlike when we do it manually, when we have it every 30 seconds or 1 minute. Some people even just take note at the beginning and the middle and at the end of the test. This is a cross-cutting project, and we're working on this, and you will learn more about the project during this year and next year. It's a regional project. That's a very important one because it's a cross-cutting process involving all the laboratories. So here a list of some titles that some institutes have been developing in their automation processes. This presentation, you'll be able to see it on the web page so that you can look at it with more time. So that's all from me, and thank you very much. Thank you, Ruben. It was very interesting to hear this map of everything that's going on in the region. And naturally, this we weren't able to read the list just now, but we will be able to read it when we go onto the events webpage, which has been shared on the chat. Our next speaker is Lars Arendt, who runs a calibration lab, and he's going to give us a live tour. Lars is a mechanical engineer and a business administrator. Since 2009, has worked in instrument calibration in Germany in different positions, such as in sales, laboratories, and general manager now. In the virtual tour, he's going to show us the automation processes in his company. That's one of the most important companies in Germany, and they provide thousands of calibration services each day. Since it's a virtual live tour, and Lars won't be able to stay to the end of this event, so please ask your questions in real time in the chat, and I will transfer them to Lars. So,
the floor is yours. We are not hearing you. Lars, your micro is not functioning. We are not hearing you. We are not hearing anything. This is part of the live experience. No communication. Lars, probably if you leave the meeting and came again in. So here the signal is your micro is not open. This is what Zoom is indicating. We can't hear you. And Zoom is indicating your mic is not open. Bueno, parece que nos ha dejado para reentrar.
It seems as though he left and he's going to come back in again.
Production.
Now
Perdón,
you are
Alexis, ¿sería posible enviarle un mensaje? ¿O un
Sí.
Would
chat?
it be possible to send him a message?
Si él ha salido y ha vuelto, él no se escucha.
He left and I think he's coming back. I'm not sure if he can hear us, but he's asking for the audio to be activated. If you have his telephone number, I can call him.
Y no sé si ha salido porque...
I'm not sure if he left.
Salió y regresó.
He left and he came back again.
Sí,
This communication problem, we'll see if we can solve it.
Ahí, Antonio, te envié su número de celular, que supongo Lars, your mic is off. Lars, you think you will be able to fix it?
Alexis, mira, estoy hablando con él y tiene un problemilla técnico.
And he has a technical problem that we're trying to solve right now.
Vamos a.
Okay.
Mientras están intentando solucionar.
Meanwhile,
Ya. Sí, bueno, while you are trying to fix it, we will open the floor for some questions to Ruben. And when you fix it, you can start. Entonces, no sé si hay preguntas a...
I don't know if there are any questions for the previous presentation, Ruben's presentation, so that we can progress with those.
Por el momento no veo preguntas.
For the time being, I don't see any questions.
So, Lars, is it possible to connect via audio through WhatsApp or something else? Please check that. Entonces hay preguntas de Roberto Chala Estrada para Rubén.
There's a question from Roberto Chala Estrada for Ruben. Data procurement in calibration processes would have to be validated. Can you indicate some general principles to take into account? Alexis? There's a problem with the audio, but we're going to try. I have it here on my mobile, and we're going to invite him to speak through my telephone so I can put my phone to the microphone. So, yes, go ahead.
Ja, das mache ich. Hello? Hello, Alexis, can you hear me?
Yeah, now I can hear you, Lars.
You can hear me? Okay. So I start with my presentation.
Yeah, go ahead.
And Alexis, would you like to share your screen?
Yeah, I have shared the screen, and it's with the first page of your presentation.
So, okay, then could you go to the fact sheet?
Yeah.
Okay, then buenos dias, colleagues. Yeah, my name is Lars Arendt, and I want to take you on a tour through our laboratory. And a few facts to us. It's a laboratory in the north of Germany. It's about 200 kilometers next to our capital, Berlin. We're an accredited laboratory. You can read that in the fact sheet. We have about 130 employees, and 50 people are working as tester. So they perform the calibration. We work in 2 shifts from 6 o'clock in the morning up to 22 o'clock in the evening. And we perform up to 3,000 calibrations a day. So we are able to do that because we developed a software which helps us with the standards, the procedures, but we also digitized the workflow. And now I switch. You have one another sheet, Alexis, right? With the workflow?
Yes.
Okay. So I give you very few information to our workflow. We have the customer, of course. We have about 10,000 customers in Germany. They send us the instruments with the letter of intent. So in a box with the letter of intent. And we have no idea before receiving the instruments that the customer will send us these instruments. So there's no time scheduling or something like that for the orders of the customer. They just send us the instruments. Then we can open the boxes and write an internal order. After that, the instruments go to a preparation department where they will be cleaned and so on. And afterwards, we have 11 laboratories here in our company, which are for several magnitudes, for example, for electrical instruments or for special length instruments or for temperature and so on. After that, the instruments will be put in the dispatch department, and then we close the order and send the instruments back to our customer. Yeah, and then after that, we charge them for the calibration service. To digitize this process, we developed a software, and our customer can use the software to administrate the instruments. They have we send our results, our calibration certificates, digital directly in that software. It's a web application, and the customer can read the results of the calibration in the internet. But they can also perform the letter of content. And now I will switch my camera and I take you on the tour. And for that, I explain one very important fact or part of our development. So as you can see here, look, this is a caliper, and here on the caliper, you can see there's a special sticker, and this sticker is a sticker with an unique ID. So with a very long number, and this number is only for this instrument, so it's unique. If the customer takes this instrument and puts it in a box, then he just can scan that, and with that he can put it on the letter of content. This letter of content can be closed by the customer, then he can send letter and box to our laboratory, and we have the letter of content, here you can see that, in the box of the customer, but we have that also in our software. So we know which instruments he will send to us. And now we can, if we receive the instruments, and I will show that you like, we can take this instrument and scan that and can check if that is on this letter of content. And we do that on our, with our computer, so on our screen. And therefore, we just need this kind of scanner, and with that, we can very easily scan this code. Okay. Okay, and now I take all of this stuff, just a moment. And take you on the laboratory tour. So, now I'll go to the receiving department of the calibration laboratory, a few meters, and it's evening time in Germany. It's about, I don't know, 6 o'clock in the evening. And here you can see the rest of that boxes. Okay. You can see the instruments, the rest of the instruments which came today, in the morning of today. These are not received yet. So we use these boxes, for example, so that it's very easy for our customer to put the instruments inside and put the data.
Así que para poner los instrumentos adentro, esto.
But we have, of course, other customer using packages, as you can see here. And in good times, we receive up to 3,000 instruments a day. So from here, we go in the receiving department. Just a moment. And this one is closed now. Just a moment. Yes. I will have a look to this working place. Here, for example, we have another letter of content where we check there's only one item on this. We check the instruments, if they are in the box or not. If they are okay, we mark that, and then we can convert the letter of content, if it's done with our software, directly in our SAP system. And with that, we have the information in our calibration software and also in our SAP system. So afterwards, here there are a few instruments, just a moment. Afterwards, we put the instruments on that kind of trolleys, and now the instruments pass through the laboratory from here to the preparation department with internal orders, as you can see here. And our employees now, they can scan the number of this internal order to give the information to our calibration software. And they can also directly scan, for example, this instrument. And with scanning the instrument, they can start the process of preparation, and after that they can check that it's done, and they can also start the process of calibration. So our software uses, after scanning this code, the correct procedure in our software and tells the staff what to do. So all instruments, after passing the receiving department, have the sticker, and that makes it very easy for us to perform the correct calibration for the correct customer. So as you can see, there are a few order here. And now I take you, this is the receiving department. As you can see, here, there are also information for the people working here that you know how many instruments we received a day or put through the laboratory. And if we are ready with our calibration service, then I show you this printer. What is the idea of that? If we close an order in our system, then our software decides if the customer is interested in a printed certificate or in a certificate as a PDF or a data file or something like that. If it's a printed one, then you can see this here, that's a printed certificate, and we put it in this kind of paperwork, and here we send this paper certificate with the instrument to our customer, and also with the information that he can use our software application cost-free. And he can send us feedback if he is interested in. That's for the case that the customer needs a certificate in paper form. Otherwise, our software decides to send the certificates digitally to our software application, and then the printer is not working. So this part, this very small part of our process, helps our staff working here that they don't have to take a decision. They just use the software, they just scan the instrument, they close the order in the software, and the software decides to print or not to print and to send the certificate. So this is receiving in dispatch. Hello. And now I take you a long way to the laboratory. So we have to pass the flyometer. It's low season here, Easter vacation. As you can see, there are a lot of empty trolleys at the moment. That's the moment. So, and here you see our first laboratory for balances and weights and electrical instruments, but we will not have a closer look to that. We will have a closer look to another laboratory. And then you can have a closer look to our preparation department. This is our preparation department, and here in this department, all of the instruments will be prepared. So we unwrap old sticker, we clean the instruments completely, and we fix a few defects if there are some. We exchange a battery, for example. This is has to be done in this laboratory, this department, and also in the preparation department, our staff is working with the computer. He scans an order and the software tells him what to do if there are some specialities for a customer. So after scanning the instrument, you receive the information what to do. If everything is done, the preparation department can put the instruments on their trolleys, and with these trolleys, the instruments go directly to the laboratory for torques or for micrometers or plug gauges or what else. And now we enter the area with a temperature of 20 degrees centigrade plus minus 1. And as you can see here, we have a few information for customer, for our staff, and yeah. So this is one of the laboratories for torques, but we will have a closer look to the laboratories for plug gauges. Ich komme einmal zu einer kleinen Tour, bin auch gleich weg. So as you can see here, there are a lot of laboratories and instruments which we use, and instruments of our customer. And yes, as you can see here, there are a lot of thread rings, and you can see all the sticker, and it's always the same. You scan the sticker that opens the procedure in our calibration software, and with that, you can start the calibration process. And in this case, the calibration process, I cannot show you that, but it's be done by this machine full automatically. So the machine is scanning the thread of these several rings. And here, for example, you can see the result of the thread. It looks very well. Okay.
Lars, there are some questions here. So the software you're using, is this a commercial software or it's fully developed by Pershman? It's an ERP?
That is just a moment. That is a software which is developed by our own. We have a lot of magnitudes in our laboratory, and that give us the idea also in combination with our customer to develop it by ourselves. And nowadays we have the software for about 3,000 calibrations a day, and we have about 3,000 customers using the same software. So they have a web application to have a closer view on our software. Yeah.
And
so we have a software department here.
Okay, and regarding the 3,000 calibration a day with 50 persons in the lab, so all the calibrations are automatized, including I don't know.
Yeah.
Name.
Okay. No.
So including all the simple instruments.
Yeah. No, not including the simple instruments, and so in some cases we can use full automated procedures and machines. But for example, here you can see a caliper, and this caliper has to be calibrated manually. If you want to calibrate that, you can scan this code, and then the software shows you what to do. So the software forces you to measure about 10 different ranges, and in this case you have to fill the result of the calibration manually in the software. You have to type it with your fingers at the end. In other cases, we have machines which can do the complete calibration. That has two advantages. In some cases, it's very quick, but in general, the impact of the staff on the measurement uncertainty is zero, because it's done by the machine, and the machine does it each time with the same measurement uncertainty and with this same influence parameters. So we try to use machines, just a moment, as you can see here, for example. Ich gucke noch einmal aus Entfernung. As you can see here, our 3-coordinate measurement machines, we use them, for example, to perform special calibrations as well, full automatically. Okay, and is there another question?
Yeah, there's another question about the QR codes and the QR seals.
Yeah.
So are they based on text or an image, or it's a link to the internet or to your intranet, so to say? And how you print this QR codes, and do you need a special material for that? For example, for thermometers, you need probably another technology.
Yeah, that's a very good question. So this sticker seems to be very easy, but we developed it for more than 1 year because it's a very special material. It lasts on the sticker for several years, so it has to be very robust. And if you can take a photo if you want, and maybe you can scan that with your handy. The content of the sticker is a code. It starts with PECAL for Perform Calibration. That is important that our scanner, and in combination with our software, can identify the code of the sticker. So the code starts with PECAL, and then it's followed by a number of, I guess, 15 elements. So this number in combination with PECAL is unique. We have it only once. And we combine this sticker with all details of this caliper, for example, in our software. So we put this caliper in our software with its ident number. This might be the 1610, and we put it in our software in the area of one special customer, and we fill in all these data. For example, measurement range 1000 millimeter, and so on. And if we've done that, if this caliper is put in our software, then we combine the data set with this sticker. And if I would now use this software, then I can scan the sticker and I find the right customer, and I find this caliper directly on my screen. And the idea of that and the code, etc., is developed by our own. And the sticker is, I think it's made by 3M. So we buy the sticker on a roll, and we have, at the moment, we have 3 sizes. This is a big one, and the smallest one you have seen, it's about 4 to 6 millimeter.
Okay, thank you. Yeah.
Okay. Yeah, then let me take you to the next measurement, to the next laboratory. Hi. Hello, da bin ich. So here we enter the laboratory for dial indicator, and that is a very interesting instrument for us, because the process of the calibration is digitized, and as you can see here, there's a dial indicator. We receive hundreds of them per day, and we can start the calibration procedure, and the camera detects the movement and the result. And as you can see here, it's done automatically, and we have another machine. It's working with another dial indicator, as you can see here, but the principle is the same. The machine is run by a software of the manufacturer, and the results will be put in our software with an interface. So as you can see here, the machines are running, and our colleague is doing something different. And here you can see nothing, there's no machine inside, but here you can see a screen of our calibration software. You can see, just a moment, you can see all the figures we measured. And as you can see here, you have the result of the calibration, and the red lines, that is the measurement uncertainty, and these blue lines, that are the tolerances, the lower and the upper. And as you can see here, this measurement is okay, and this line is not okay, because this measurement result is on the directly on the tolerance. And with this information, you can create the certificate. So all infos are put, in this case, per interface in our software. And if you now want to print the certificate, you just have to, or if you want to close the calibration, then you just have to close it. And I can show you the calibration certificate. But I've checked that before. Kann ich hier auf Kalibrierschein-Vorschau gehen, oder ist dann irgendwas zerstört? Ja? Okay, ich gehe nochmal auf Vorschau. Okay, just a moment. So here you can see the certificate with a lot of information for our customer. Also with the information if it's usable or not. And this kind of result we discussed before with our customer, and we have procedures that we take the decision in the name of the customer, if it's okay or not.
Can you show it lower, please?
Lower, sorry, yeah, okay. Okay, now we do not print the certificate. Years ago we did that, but nowadays we just close the calibration and everything is done. We don't have to sign that. It's automatically signed, as you can see here. It's checked by the software, and so the staff here has to fill in a few parameters in our calibration software. Then, if it's a second time, you just have to scan the sticker here. This is the instrument we calibrated. In many cases, the calibration is done by a automatically system, as you can see here, and the automatically system then sends the data in our calibration software, and we have the calibration result without influence of the tester. That makes the measurement uncertainty very stable, of course, without impact of the tester, and the tester now can check if everything seems to be all right. Then he can close, or she can close the calibration, and in the dispatch department, the software decides if the customer want to receive this certificate as a PDF or a printed form. If in printed form, as you have seen before, the printer will print, and we send instrument and certificate back to the customer.
Lars, can we stop here? We have some questions on this place. So one is, how do you calibrate the camera to capture the right number at the nail indicator?
Yeah, for that we have this is, for example, a digital one is a very special example, of course. For that we have a calibration system. So we calibrate the movement of our system, of course, and we have a system with which we can calibrate to detect the needle and to observe the movement of the needle. Therefore, we have a special system, calibration system.
Okay.
I can not show you at the moment. No.
Yeah. Okay. The next question is, when you implement this software and also as part of your service, what is your experience about the audits on 70025? So from the accreditation body, do you have challenges?
Yeah.
You have to what do you have to prove?
Yeah. So we develop calibration software since I guess 1999. So we are at the end we are experienced with that, and of course the accreditation body has a very close look to that. They are at the end they are interested that we detect the correct deviation, as you can see here. So they take an instrument to our laboratory, then we have to measure it, and they are interested if we detect the correct deviation, and then they are interested if we are able to calculate the correct measurement uncertainty, and that we are able to calculate if the instrument is okay or not. And that is the main topic at each audit, of course. The accreditation body is not interested in the customer's application. So they know that we have that customer's application, but they are not interested in that. The customer application is detected by their ordered at the customer, for example, according 9001, ISO 9001 or something like that. But at the end, all data are in the same software.
Yeah. Okay. And the next question from Claudia Santos is, so you have your quality control processes and quality control activities also automatized?
Yes, they are. Oh, I cannot show you here. I'm sorry. Maybe. Ooh, I'm not so familiar with testing, but okay. Yes, that is complete automized. So as you can see here, just a moment, we can choose a customer, we can choose a item, and
can you focus nearer? We cannot see it.
No, I cannot focus, but I can. Yeah. Okay.
Yeah.
So
okay.
We have that also in English, but I guess
no,
I can
don't move anything.
switch. Yeah. Okay. So this is the customer. We can choose the customer or the instrument, and combine everything: instrument, customer, etc. All these data are combined with the sticker. So if I choose, if I scan the sticker, I'm directly in this customer, and then I can directly start the calibration procedure. So here you have some information to our reference we use for the calibration, and I can not show you the procedure because in this case we import the data per interface. If we talk about the caliper, our software would now suggest to calibrate the item 0, then 41.3, and so on. So the software forces me to follow special steps and to put the result in the software. And the software also gives me some information for the sticker on the of the result. So in this case, the software tells me the instrument is okay, and the software tells me, please put a sticker on that instrument with a recalibration in 2024, in April 2024, because this customer asked for a 24-month cycles. Here you can see this is the wish of the customer, 24 months, and he can, this information, 24 or 36 or 12, he can put in his application and we can read it directly in our calibration software. And the number of months, for example, 12 months, directly influences this sticker shown in our software.
Yeah,
so
Lars.
That is optimized. Yeah.
Lars, so we have more questions, but we have only 10 minutes more. So I don't know if you want to move, and I make the questions. And you are at the end.
The idea was to stop here.
Yeah,
because normally we have another 2 minutes. So are there any more questions?
Yes. So the last question was if the quality controls, if you make it also automatized, so only through this graphs you did it or you perform it.
Yeah.
Is that right?
There's another kind of control. So if the instrument passes the dispatch department, there's another software solution. So in some cases, it gives us the information, please check the complete order. So we have to check if all certificates are in the package. We have to check if all stickers, as you can see here, the red sticker, are correctly on the instruments, and we have other measurement points we have to check. Also in the dispatch department, the software helps us because in we can mark special customer where we detected complaints in the last month. So we can mark these customer to have a special dispatch department check. And in other cases, the software counts a special number and then give us the information to have a special check.
Okay. So the next question from Sue Durga is, which database management was used and what software, what platform was used to develop the web application?
The software is Java, as you can see here. And the database, I have to send you, it's a very common from Microsoft, but I have to check that. I can send you it later on in the chat or as an email.
Okay. And these automatized measurement systems that you have developed, are they patented or and you also sell that?
We sell the software, of course, but we do not. We have no patent on that. We have a copyright on our sticker. So it's more or less secure, but the idea of the sticker is so common, it's specialized for our laboratory, but the technique is so common that you cannot have a patent on that. So only our software is sold by us. And we have a few customers which buy these unique ID sticker. So this one here. Yeah.
Okay. And regarding the measurement uncertainty, so the fact that you implement your calibrations through machines, what are the contributions to the measurement uncertainty by the machines?
Yeah, as you can see here, for example, of course, we have several impacts. Here you can see the temperature at the moment of this calibration, the density, it's not shown here, but we observe the density. And of course, we have two very big impacts. In this case, for example, the biggest impact is the impact of the instrument itself. So in this case, you have a dial indicator, digital, with a resolution of 100th part of a millimeter. So for this item, we have a measurement uncertainty impact. And then, of course, we have the whole system. And here we have we do the calibration of that, or there's another company. In this case, it's done by a supplier, the accredited calibration of that. And of course, we use the measurement uncertainty of that calibration as one impact in the complete measurement uncertainty.
So thank you for that. A question from Diego Copa. So which is the instrument or piece you most calibrate in your laboratory? Which is the typical instrument?
With the highest number?
Yes.
That is, I guess it's a plug gauge. So we do maybe 35,000 calibrations of plug gauges a year. It's the instrument with the highest number.
Okay, so I will jump through the questions. So from Karina Gonzalez, in the case of mass, how do you realize or how you solve the topic of the seal with the QR code?
Labels.
Yeah, we put it on the box. Of course, we cannot put it. So there are a few instruments where we cannot put the sticker on the instrument, of course, as mass, for example. So we can put it on the box of the weight. And in some cases, we can only use the ident number, which is shown on the mass, for example, if there's a laser number on that or something like that. So at the moment, I would say in 99 or 98% of all instruments we calibrate here, we can put a sticker on that, but at the end, of course, there's a number of items where you cannot put a sticker because the sticker is changing the measurement result or destroying the instrument. Yeah.
So two last questions, and please very short answers. From Christian Paredes, so would it be relatively easy to incorporate the XML-based concept of DCCs to your software? Could they be generated as straightforward as you generate the PDFs?
It's very easy. So the shortest answer is yes. We plan to do that in the next weeks.
In the next weeks?
Yes.
Okay.
For all instruments we calibrate here. Mm-hmm.
So you will use the DCC for that?
We create the XML as a result, but our customer cannot use that. So it's we are a member of that project, and we want to create it in our house, just to get experience with that. But at the moment, we have no customer who is able to read the DCC.
Yeah, and it seems that your answer of this question was not satisfactory. So it's again there. So how do you calibrate the camera to take the right value of the nail indicator?
Yeah, we have a special standard for that. And with that, we can check the camera. So on the one hand side, we check the range, but for that, I can, I'm sorry, I cannot show you that. We have a, at the end, we have a standard where we know the angle, for example, of special marks or the way, the distance of special marks. And with that, we can check the camera.
Okay, so thank you very much, Lars. Lamentably, we have to close here the question session, and also thank you very much for showing us your laboratory. And
yeah, you're welcome.
Thank you.
Yeah, thank you, and. Buenos dias, so long. I guess your day started.
Hasta luego.
Bye-bye. Thank you. Yeah. Bye-bye.
Bye. Muy bien.
Good.
Bueno, después de este tour.
After that tour that was a bit complicated at first, but I hope you were able to take advantage of the tour through the laboratory and of Lars's experience too. Now we're going to go on with the last presentation, and I apologize, Roberto, for the delay, but this is the perspective of a secondary laboratory related to automation. Roberto Benitez is the representative of a company called Etalon in Mexico. This laboratory provides this service through an electricity consortium in Mexico. And he participated as a national advisor in Mexico, and he runs a calibration laboratory in Mexico and is one of the largest independent companies in Mexico. In 2010, he started an accredited testing laboratory, and this is he also provides training and consultations. He has been certified by ASQ. That was in 2012 that he started a biomedical laboratory equipment calibration service, and he participated in a measurement conference in California, making presentations between 2017 and 2019, and some presentations in Senam in Mexico too. So please go ahead, Roberto, with your presentation. Thank you very much. Can you see the screen? Could you confirm that? Yes, we can. Good, and I hope you can hear me well as well. Thank you to the organizers of this event for inviting me to make a presentation regarding industrial metrology, and thank you for your time. Also, those of you who have joined us for the transmission of this event. The title of this presentation, as you can see, is the perspective of a secondary laboratory for calibration services. And on my screen, you can see that I gave it the name Digital Metrology in Practice, Metrology 4.0 for Industry 4.0. In this activity of metrology we're speaking of here in the forum, which is metrology for digital transformation, I've had the good fortune and experience of seeing several changes in the transformation of calibration services. In 1980, I was responsible for a calibration laboratory of an industrial consortium in the electrical area in Mexico. And because of requirements of the nuclear industry of that year, 1980, this company sought to calibrate, as the standard states, all of the inspection, measurement, and testing instruments that could affect the quality of the product. Based on this, we sought to find a way to calibrate these instruments, all of the instruments involved in the process of manufacturing these products, electrical products in this case. So in 1980, some of you might remember that computers were incipient during that period. So most of the instruments were mechanical ones, or some of them electromechanical. And we're speaking here about resistant measuring devices that used an optic system to project light on a scale so that we could see the disbalance and the current in order to measure the electrical resistance of the device. So all of the instruments, or most of the instruments rather, were ones that the industry calls analogical instruments. And with mechanical micrometers and mechanical calibrators, as has been presented earlier. So to calibrate them, we used mechanical devices too, and these mechanical devices still continue to be used by some laboratories for measuring or for calibrating the source of resistance of electrical conductors. So Thomas type resistances were used based on wire with a defined resistance for calibrating resistance. So during that period, when we had to calibrate that type of instrument, we sought to comply with the traceability of these measurements in accordance with ISO. And for this company that I worked for during that period, we consulted a laboratory in another country, that was in Canada. We wanted an accredited laboratory for the calibration services. So at that particular time, we hired when you hire a laboratory from another country, well, that was the beginning of the on-site calibration service, because it was necessary to send the patterns to Mexico. So from that period of time, we started with this calibrations on-site calibration service, including transport of the instruments and the methods for on-site calibration, considerations of uncertainty, and these were some questions that emerged in the previous presentation too, where participants asked about the calibration of an instrument on site and in a laboratory, the difference between the two. So it's important to take these considerations into account, how you carry out calibration, on-site calibration of an instrument. So with the arrival of computers, which was during the 1980s, by the end of the 1980s, we were seeing the first personal computers. So that was a transformation of metrology, or of the calibration of using electromechanical instruments. We started using digital instruments where you could see the magnitude of what you were measuring. In digital format, you could see the displacement or the pressure or the temperature expressed in digits in a screen on the instrument. I apologize. I don't know what's happening, but we can't see the presentation. You've got 15 minutes. Oh, yes, here we go. So in this first transformation, we defined our mission as a company, which was to increase business opportunities for our clients using technological leadership with experience and quality. So this was what has led to all of the activity that we've been involved in, maintaining technological leadership. So specifically in January 1994, I left that company and I established this laboratory, which is an independent commercial laboratory, and we acquired then in 1994 one of the first multifunction calibrators that existed, and we used that was being used in Europe, and we started doing calibrations. And we can start to call them here digital calibration. We're already starting with that. That was at the beginning of the 1990s with the multifunction calibrators. You introduced an automatic program, cards that were produced to obtain automatic readings. And it was possible as well to send these to a printer, a point matrix, and so this was how we started with digital calibration. Also the projects of NIST, which is a company, we're an up-to-date company, and we take advantage of these. So John Kitching from NIST began working on the chip-scale atomic clocks. And this is what we aim to have, an international system of digital units. And this is what the PTB has been presenting. We're working on the international system of digital units. So this is how we've kept up to date, and we have attended conferences organized in the United States through the National Metrology Conference. We've participated, that's from 1990. We've participated in the last 10 years, every year, presenting some papers. We've also attended international metrology conferences of the CIM in France and events organized by IEEE in Brescia in Italy, for example, which was Metrology 4.0 and Internet. This was 2018, and then in 2019 in the Metrology Congress for 4.0 industry and IoT, And so we have remained up to date in our laboratory. What developments have we implemented? Specifically here on this slide, you can see that during one of the first meetings when we spoke about Metrology 4.0, that was in the International Congress of SIM in Paris, France, 2015. There was a session specifically during which we discussed Metrology 4.0, and we participated in that meeting. After that, we were invited as speakers to this symposium for Industry 4.0 and Internet of Things, and regarding the calibration of sensors for Metrology 4.0. After that, we made another presentation on wireless calibration for Industry 4.0. This was a paper that we presented in the CIM in 2019 in Paris, France. With all of these developments, what we did in the last paper, which was wireless calibration for Industry 4.0, this was wireless. During this event, we presented something that we had done of a wireless calibrator, completely wireless, used based on a bank of rechargeable batteries. And it has the standard for it takes the temperature through a temperature sensor, a platinum resistance thermometer, which then sends the reading, the temperature reading, via Wi-Fi to a mobile device that the metrologist has, who is controlling the process. Let's remember that Industry 4.0 right now doesn't have analogic instruments, and in the industry, colloquially, we say we don't have any more needles. We don't use these for the process. We use apps to control the process in the mobile device. It could be using the tablet or a phone, a smartphone, or the computer. But the process of Industry 4.0 doesn't use these devices that show the reading of how the process is working. The only thing that we see are elements, passive elements, that send a signal, whether it's wireless or not, to a device or to a computer. So how can you calibrate these instruments that really aren't multifunctional instruments anymore? They're not digital calibrators with a measurement interval from 0 to 25 milliliters. It's not a digital multimeter. These are instruments or sensors, which is what we call them in the industry, that we look at them specifically. We look at the temperature, which is set for the process, and it needs to be maintained at this control point. So how can we calibrate these sensors? That is where I want to make a proposal. It's a personal proposal. It's the final product of all of the calibrations. A digital calibration certificate isn't the final product of calibrations. The final product should be measurement of how the process is working, how we are currently carrying out calibrations. We use these calibrators, the wireless ones, which send indications about the temperature, for example, to a mobile device of the metrologist who's carrying out the service. This person observes the temperature and introduces the value in his mobile device or in the computer. And when concluding the different calibration points, so this is just an example, a thermometer, a digital thermometer, or a temperature sensor, when these points that have been defined for measurement have been concluded, then you click on send in the app, and automatically this, through a template, of course, and a whole process that in the metrologist has, automatically this becomes a document, a PDF document, and it is uploaded to the cloud. And so the user at that particular time already has the calibration report in their device, computer, or file. And this is what we've called a real-time calibration. And that's what it is, exactly. But what is it that the user actually needs? We're going to look at this a little bit later, but through these developments, we have a platform in which our users can register on this platform, and we can follow up on their service order. We file all of the reports of devices calibrated. It's managed on a platform that we've developed and where to which all of our clients have access and in which they can interact commercially with our laboratory. Another of the developments that we have made recently is the request for a calibration service. It's very common now that you do it through an application. These developments with the pandemic were a great opportunity for us. Why not request this calibration service? So we have that platform, and it is in which users who want to calibrate an instrument simply put in the name, enter the name of the instrument or the location or the magnitude of the application, and immediately you can see on screen which laboratories are close to your location or which laboratories are capable of calibrating the specific instrument. We will have calibration services that are can be used very easily. It facilitates their use. So in a question of minutes, they can actually have this service in their plant. This is a development that we want to provide the user with. The user doesn't want a document that he's going to have to file. What the user wants at present is to know how his product is functioning and if it complies with the necessary characteristics, or if the process is within the established parameters and if it's working appropriately. So I don't want to have to go into the files and look at what happened 6 months ago. What users require in Industry 4.0, for example, when we're speaking about the assembly of vehicles, what's the parameter that I need for the parts for the automobile? But I want to know the situation, the status right now, not 6 months ago when it was calibrated. I need to know right now if my process or product is complying with the specifications there and then. So this is what I need. Real-time calibration so that I can interact with the process directly and manage to guarantee, have the metrological guarantee that the quality and the process are working under the appropriate conditions. So that was my contribution then regarding industrial metrology, and that's my viewpoint as well as a secondary laboratory. We need to focus on the real needs of the industry. What is a process? What does a process engineer require? In addition to certain developments regarding digital transformation, let's also focus on physics, pure physics. You can see here in this slide that we have a calibrator to measure gas flow. And this is an instrument, a mechanical instrument, to measure the diameter of the bell shape, and it is directly a secondary standard for gas flow calibration. So as a company, that is our mission, to improve the quality of products and to guarantee measurements as part of an industrial process. So that brings me to an end. Those are my processes. You have my email, and I'm here to answer any questions that you might have or comments. Thank you.
Muchas gracias, Roberto, por esta muy plástica descripción de la historia, de tu historia y de tu aporte a la metodología para la
Thank you,
transformación.
Roberto, for your very plastic description of your story of digitalization. Thank you for sharing all the development you have there. And are there any questions? We are very short on time, and I'd also like to thank Ruben, Lars, and Robert. You only have Ruben and Roberto here. We'll see if there are any questions, because we are actually over time at this point. Thank you, Roberto, because you answered some of the questions that are already in the chat. Yes, thank you so much.
Bueno, si no hay preguntas,
If there aren't any questions, we have actually shared the page for this event, where we've shared the presentations, and we'll be able to contact the panelists.
La liga de la página web del evento. Entonces,
and so if there are not any
si no hay más,
if there aren't any questions,
doy pase al doctor Héctor Lais.
I'm going to Héctor Lais.
El doctor Héctor Lais es gerente de metrología, calidad y ambiente en el...
Is a director of meteorology, quality and environment in INTI, Argentina. For the International Committee of Weights and Measurements, he's the executive director of CIM. And he is president of CIM since 2015 to 2018. Go ahead, Hector, please.
Bueno, muchas gracias, Alexis, por la presentación.
Thank you, Alexis, for the presentation. And I'd like to thank you. I'd like to thank the presenters of this workshop. It's been very, very interesting. Also very important for those of us that work in the National Meteorology Institute to have the contribution of the industry, so to speak, secondary laboratories, calibration. Sometimes there are intermediaries.
Concretas en materia de metrología, como bien señalaba.
Like Roberto just mentioned in its presentation.
Y conocer las vivencias y las experiencias y las necesidades que ellos relevan en el trabajo.
This is important that that they face the needs of the everyday needs of what's taking place in this field. I'm closing for the CIM's board council, and basically we have the digital contribution of CIM, and this component of the project also has the support of PTV. So CIM is actually a new experience. Basically with the institute that we've been working throughout the years. For us, it is very important, and it is a satisfaction because we have managed to add partners of which we have so much expectations and with which we have worked so much in the past years. And so this project, this work for meteorology towards digital transformation is within an initiative from SIM from the past years, that is to support the development of meteorology for digital transformation within regional institutes. SIM keeps it as a strategic axis, and it's created a few years back a new work group that has actually been spearheaded by Hugo Gasca from Senam and from INTI. And this is a group that has developed so many activities and that is really having quite a notable impact in the SIM institutes. Furthermore, this work conducted by SIM, as Alexis mentioned, is part of an initiative, an international global initiative that has to do with supporting the development of the necessary technology for the fourth industrial revolution, in which all our other regional meteorological institutes and the Weight and Measure Board is actively working to provide that basis that methodology needs to provide so that digital transformation in the industry is displayed as we all expect, and that hypothetical absence of meteorological tools does not become an obstacle for the deployment of digital transformation in the industry, particularly in countries with great, not with more development, but those countries with intermediate development that do actually need for promotion of regional organizations and development of these capacities. So thank you so much for the support, for the contribution that you provided today, and doubtlessly this will be an invaluable tool that all metrologies that attended the workshop will be able to really take advantage of within the next few days. I believe the discussion is until Friday. Yes, the workshop goes on until Friday. We are very active and we will continue on the next hour with the participants of CABURK. Great, thank you so much. Thank you, Alexis. Thank you as well for all the efforts you make. Thank you, Hector. And I'd also like to share your appreciation to our colleagues who have helped us with the streaming, colleagues from Senam in Mexico, INACAL Peru, INETEME Paraguay, Senamep in Panama, and also Antonio Matamala, who had to actually run the connection spontaneously with Pershman. Thank you so much. And so with this, we close this event. Thank you so much. Please, panelists and hosts, if you can stay a little bit, because we are going to take a picture in Zoom. We will see each other at 17:15 UTC using the other link. Thank you.
Carlos, ¿avisa cuando está finalizado el streaming?
Carlos, let us